and opening the secrets of the universe. Its exposures concerning the progressed exoplanet have space specialists murmuring as it might show basic terms of occasions concealing on a deeper level for a widened period. The mission for finding life past Earth has long entranced mankind, and with the James Webb Space Telescope, JWST, this excursion could after a short time turn into reality. The telescope lately uncovered an enchanting secret in Proxima Centauri, the nearest star structure to us. Among its planets, Proxima B stands separated with specific fake lights, leaving the intellectual neighborhood spellbound and enchanted. Could this any time be the long-expected evidence of smart life past our planetary structure? How do researchers choose whether these lights suggest the presence of smart life on Proxima B? Oblige us as we plunge into how the James Webb Space Telescope recognized metropolitan lighting 7 trillion miles from Earth. People have always been emphatically curious about the secrets of the universe, and through mechanical movements, our regular drive to explore the Earth and sky continues to push us forward. Despite many long stretches of progress, Earth remains the principal planet known to have life. The well-established question gets through. Are we the sole tenants of the universe? Or are there city foundations concealed among the stars waiting for us to discover them? To answer this troublesome solicitation, American cosmologists Jill Tarter and Thomas Pearson began a venture called the Quest for Extraterrestrial Intelligence in 1984. This charitable effort revolves around spaceborne radio transmissions, which could go about as probable strategies for extraterrestrial correspondence. Notwithstanding significant stretches of checking the sky for trustworthy signs, there is still no convincing verification of signs from an extraterrestrial human headway. In any case, late reports from NASA proposed that the JWST might have recognized fake city lighting from adjoining planets. Is there any substance to this ensure? We ought to figure it out. The compelling dispatch of the James Webb Space Telescope signifies a basic forward jump in humanity's understanding of the universe. Arranged around 1 million miles from Earth, this massive telescope fills in as our window to the earliest times of the universe, revealing in advance unnoticeable insights and encounters into the course of action of stars, planets, and other divine bodies. Cosmologists utilize the JWST cameras and channels to get and examine the complex spectra, including grand items. Through the JWST, specialists can gather valuable data about the substance associations and genuine properties of splendid bodies in the farthest reaches of the universe. They achieve this by isolating unequivocal frequencies of light. Beyond fundamental insight, the JWST analyzes and investigates the atmospheres of exoplanets for traces of life. Its astounding expertise to see past the constraints of the real world has prompted the absolute generally stunning exposures. For example, through the telescope, space specialists have seen as more mass than as of late known to exist in the universe, hid in different gigantic universes. This finding troubles earlier considerations regarding the plan and level of the universe. With humanity's confirmation to investigate the farthest extents of the universe, the JWST is prepared to be a critical gadget in unraveling the privileged insights of faraway grandiose frameworks and making arrangements for new astrophysical exposures. Just 20 years delete past our nearby planet bunch, remain to a great degree dark, with no known planets. In any case, cosmologists have since found more than 4,000 exoplanets surrounding distant stars, an exhibition of human inventiveness and creative progress. As indicated by NASA, this stock might be just the tip of the magnificent iceberg, showing the presence of trillions more exoplanets scattered all through the universe. In the serious journey for extraterrestrial life, analysts keep on exploring the likelihood of tracking down untouchable areas past our past understanding. During the Galileo rocket's journey to Jupiter, its spectroscopic instrument distinguished a clever ghost engraved showing earthbound vegetation. This wonderful exposure meant the beginning time experts saw a biosignature, the vegetation red edge, unquestionably showing outside life. By focusing in on how it reflects light, the JWST should reveal the requests incorporating extraterrestrial conditions. It will achieve this by means of carefully analyzing the orbital cutoff points of perhaps reasonable exoplanets, considered inside the legitimate zones of their untouchable parent stars. Once recognized, these signs could go about as basic confirmation in the search for astute life past our planet. As light goes through the air layers, the isolated light is ingested to convey various frequencies by the particles and atoms in these layers. This ingestion prompts an astounding, ridiculous model like unquestionable fingerprints that can be interpreted through spectroscopic appraisal. It is conjectured that when light from a star shows up at a planet, the JWST will be competent to isolate it as it enters the planet's environment. In this way, the JWST will be key in revealing the air creation of remote exoplanets, a significant sign of their genuine limit with regards to Earth-like life. Earth-sized planets with environments well off in oxygen, nitrogen, and carbon dioxide, like Earth, could hold conditions supportive for life as we likely are aware. However, the setback of expected parts or the presence of remarkable blends could illustrate elective sorts of life or even mechanical headways. Inquisitively, the identification of chlorofluorocarbons, CFCs, which are man-made compounds generally used for refrigeration and current purposes, could help the JWST in showing the presence of an extraterrestrial human advancement. If the JWST notifies such fabricated compounds in the environment of exoplanets, it will open new areas of solicitation for extraterrestrial development outside our planetary system. This addresses a truly invigorating test for cosmic specialists, opening another doorway into the barometrical game plans of various universes and the opportunity of charming civilizations. The smooth way the exposure of life past our arrangement planet is portrayed by different potential results that go beyond the obstacle of intrinsic science. While we envision life as thriving in quiet conditions like our own reality, it might be broadly more different and outrageous. For instance, extremophiles and an interesting gathering of living things, pervasively occupied microorganisms, thrive in conditions for the most part portrayed as outstandingly silly. These solid living things can without a doubt make do and even thrive in conditions typically considered significantly ungracious. As such, the endless components of the universe and the horde conditions related to it let us know that our excursion for extraterrestrial life ought to be sweeping. Despite reference planets, for instance, Earth orbiting around stable sun-like stars giving authentic potential important entryways, we ought to similarly consider elective circumstances promising opportunities for assessment. For instance, exoplanets orbiting red small individual stars, which are more ample in the universe. In disdain of their lower splendor and cooler temperatures diverged from our Sun, they offer splendid possibilities to explore the potential for life in different circumstances. The long life anticipation of red little stars gives ample chance for the sluggish complex examples of life's ascent and improvement to spread out. Seen as approximately 40 lights seemingly forever from Earth, the TRAPPIST-1 planetary structure stands out as an incredible focus for the JWST mission. This fascinating system, containing a powerless red little star and 7 Earth-sized rough planets, circles the peaceful red little star. 3 of these known planets are thought of as legitimate and may perhaps have water on their surfaces. In any case, more unpretentious and cooler than our Sun, the TRAPPIST-1 star exudes light suitable for supporting life on its surrounding planets. Among the various stars in the grandiose social class, Proxima Centauri stands as a sort of reference point for likely viability. Basically 4.25 light-years from the Sun, Proxima Centauri is the nearest star to our own. However, its faint sparkle suggests that any decent planet orbiting it ought to keep a close-by distance. The distance of any valid planet to Proxima Centauri ought to be about on various occasions closer than Earth is to the Sun. Without meeting this condition, none of its planets can maintain life, keeping up with conditions like our planet. In a captivating revelation on August 24, 2016, cosmologists tracked down a planet with 1.3 times the mass of Earth saw as inside Proxima's reasonable zone. This Goldilocks-like nearby gives a delicate harmony of light power absolutely sensible for mellowing ice for water and conceivably supporting the seeds of life. Proxima B presents an enormous issue, circumnavigating around Proxima Centauri, its host star. This planet, which is essentially 4.6 million miles from its little red star, faces a large number of challenges to supporting life. Proxima B's potential is exceptionally close to its host star, presenting it to strong sunlight-based breezes that could strip away its climate and render it fruitless. In spite of these cut-off conditions, Proxima gets sufficient sunlight to stay aware of Earth-like temperatures where water is in a liquid construction. At any rate, the planet's close-by circle presents streaming locking, driving one side of the equator experiencing steady high daylight, while the other experiences outright darkness. The situation looks like the Moon's relationship with Earth in our planetary system. With just 18% of the mass of the Sun, Proxima Centauri exudes basically less light than expected. Coupled with its proximity to Proxima B, just 5% of the distance among Earth and the Sun, Proxima Centauri goes against traditional assumptions, illustrating that Proxima B may not be a customary planet. Rather, it might hold hidden-away secrets. The JWST discovery of light sources like Earth's phony lighting on Proxima B has incited scientists to consider the believability of extraterrestrial life. Astrophysicists surmise that future consistent data will solidify Proxima B as a competitor for extraterrestrial life. The brightness plans on Proxima B are immovably checked by the JWST. On the off chance that these plans keep up with consistent splendor and are completed and oversaw, it might suggest a convincing sign of brilliant life. While the mission for signs of something happening on a deeper level continues to bring out dazzling and interest, it isn't yet evident whether these models will finally go about as unquestionable proof of clever life on Proxima B. Proxima B may not be the impacting prediction one would expect for a planet so close to its star. Paying little mind to the difficulties introduced by its close-by circle and the normal loss of its environment to sunlight-based breezes, Proxima offers persuasive open entryways. On the remote possibility that it harbors a protective air prepared for getting power, the presence of an air on Proxima B could show the presence of oceans and raise the chance of life. The test to perceive standard designs on Proxima B has upheld the theory that such living things would be able to have devised sharp solutions for route the planet's rude conditions. One enrapturing thought suggests sending gigantic sun power chargers across Proxima B's dayside. These sheets would harness the star's energy to illuminate and warm the on dull and cold night side, perhaps changing the destroyed scene into legitimate zones that could maintain life. The revelation of Proxima B has ignited a heated race among space specialists to determine whether adventures at stars face as seen from Earth. These movements could enable scientists to measure the planet's size and mass, determining its thickness, ascertaining its rough piece, and giving insights into the materials that make up its stones. Besides straight going through Proxima B's environment during these movements gives snippets of data about the plan of its current circumstance and its reason. In any case, the chase to unravel the mystery of Proxima Straits and need driven by man's insatiable craving for data and the believability of other life structures past our close-by planet bunch. Another component to consider is Proxima Centauri's wild nature, prepared for immense flares. This adds multifaceted nature to exploring the decent universe of Proxima B. Cosmologist David Kipping from Columbia School depicts the star as erratic, highlighting the test introduced by its variable warming models. While rough planets generally hold sunshine and release infrared radiation, Proxima Centauri shifts its infrared mark shifts from that of its host star, giving a clever open entryway for insight. The James Webb Space Telescope goes probably as the hero in this endeavor as it can distinguish infrared frequencies. Proxima's remarkable infrared power imprint will help us with tracking down the insider realities of its environment. The high-level infrared abilities to image of the JW are totally ready to uncover the secret of Proxima B's air arrangements and give novel pieces of information into the conceivable outcomes of life on it. Also, the JWST's infrared mindfulness loosens up the investigation to Proxima B's nightside. Paying little heed to the mind-boggling task of perceiving faint phony light against tremendous darkness, the JWST's pattern-setting development licenses it to recognize even the smallest gleams of light. The James Webb Space Telescope might have the choice to affirm the pieces of gossip about city lighting on Proxima's evening side, paying little heed to whether they were essentially as delicate as the we buy and buy use around nighttime. Although Proxima B's excellent climate presents challenges, it as well presents a charming relationship between its surface features and divine associations. By seeing the proportion of temperature assortment, space specialists can obtain significant pieces of information into Proxima's climatic development. With its unmatched infrared imaging abilities, the JWST will examine the planet's warm outpourings, giving huge information about its natural properties. The JWST circle around Earth lines up with Proxima's orbital length, working with relentless impression of the two its constantly sides within 11.2 Earth days. Tolerating that Proxima B has an air, the ensuing stage is to separate its climatic science to check whether it could maintain life. Certain gases, for instance, oxygen, water, smoke, or even methane if present, are incredible indications of reasonable circumstances and the potential for life. Separating these gases requires getting and separating light emanates communicating with or passing through Proxima's air, a naturally testing task. While the James Webb Space Telescope gives basic entryways for depicting planetary environments, its fundamental mission is different. The telescope is on a very basic level tuned to concentrate on methane, carbon dioxide, and water rage centers, disregarding the way that it is restricted in perceiving access the next level, oxygen, a strong sign of life. Despite its limits, the JWST may anyway have inspirations to search for various materials. This integrates ozone, which can give information about the typical level of energy in the planet's current circumstance. Additionally, the JWST doesn't have through and through capabilities, and its look is limited to 3 of the ever-closer bearable universes. To coordinate a more broad barometrical assessment, cosmologists are going to ground-based observatories like the Extremely Large Telescope, ELT, plan to start exercises in 2028. The ELT is strangely arranged to dive further into the climatic course of action of remote exoplanets, giving invaluable information into their bear. As we energetically expect the course of action of future space telescopes, the James Webb Space Telescope remains a fundamental gadget in opening the special experiences of the universe. Through its unrivaled capacities, it continues to stretch the boundary of our comprehension, offering expect new revelations and revelations about the mysteries of faraway universes.